I wonder why we eat. Like, what would happen if I didn't eat before a game?
I can tell you why.
Yo, God, is that you?
No, it's us, Flo and Mary Ase, the Ase Enzyme Sisters.
Yo, what's up? I'm Kyrie.
We heard you asking about what would happen if you didn't eat before a game. We're here to answer your question.
It's all about glycolysis.
What you say?
Glycolysis, it's the breakdown of sugar.
I know all about the breakdown.
Not that kind of breakdown, silly. We're talking about the breakdown of glucose to get ATP.
What's ATP?
Oh, ATP is a super important energy-rich molecule made up of 3 phosphate groups that can be used to power many reactions in the cell. Think of it as the currency of the cell.
Tell me more.
The process starts in the cytoplasm, the liquid that forms the cell and is outside of their organelles.
When we eat, our cells import sugars like glucose, which has 6 carbons, into the cytoplasm to start off the process. There are 3 important phases. The first is the investment phase. After all, you've got to spend money to make money.
Just like...
Exactly. The investment in this case is 2 molecules of ATP. The glucose we've ingested uses the ATP to gain a negative charge, is then trapped inside the cell. This makes it super unstable, so it'll readily break down, and it increases the polarity so it won't try to escape the cell.
The next phase is cleavage, breaking glucose, a 6-carbon molecule, into 2 smaller 3-carbon molecules called G3P. We're one step closer to getting the energy that helps you make all those 3s.
That's super important. What's next?
The last phase is the recovery phase, where you finally make money off of your original investment of ATP. There are a few important steps we skipped over, but one that is too important to skip is step 6.
6 steps? That's a travel.
No. Step 6. It's what allows us to double our profits. At this point, each G3P has a single phosphate, and it gains 1 more by using the energy of the reduction of a molecule called NAD+ to NADH.
I thought we got the first phosphate from ATP.
We did. The second phosphate is inorganic, which means it was in the cell all along.
With the help of some of our enzymatic cousins, we can turn each 1,3-BPG into 2 molecules of ATP. Isn't that crazy?
I mean, it's okay.
Okay, this is a crucial step in the process that makes it all worth it. Now our net yield of ATP is 2 instead of 0. We haven't just made our money back, we made more money and...
Flo, I just don't think he's that into it. It's okay.
So what happens with ATP?
It's what allows you to do crazy things like this. You spend ATP everywhere in your body. It allows your muscles to contract and your brain to fire and come up with plays. ATP is involved in everything, my guy.
I guess that's pretty cool.
Also, it doesn't end there. There are other steps like the Krebs cycle and the ETC that allow for way more ATP after glycolysis. These are really where we get our money's worth.
Whoa, when you put it like that, it makes a lot of sense. Well, I gotta run to practice. Thank you so much for teaching me about how our bodies can do crazy things with just the power of glycolysis.
Anytime. Now finish your food and make us proud.
And don't forget to break it down, Kyrie style.
Why were you late to practice, Kyrie?
I was just talking to a bunch of enzymes and they told me about glycolysis.
Wow. Kyrie is different, isn't he?